Autovan sells new cars and second-hand cars. The property of selling new cars is zero point 0.4. The sales of new car and second-hand cars are randomly distributed throughout the week. A. For a particular week where the company sells 20 cars, find the property that first, at most 5 new cars are sold. Second, more new cars are sold than the second-hand cars. So let us answer the question A first. The clue is 20 cars and the probability of selling new cars is zero point 0.4. So our x is, which is the random variable, describe about the number of selling new car, where the distribution is binomial with n is 20 and p is 0 0.4. So the probability of selling new car and the variable must also describe about selling new car. So the probability is 0 0.4. Now, at most 5, find the probability that at most new cars are sold means that probability of x is less than or equals to 5, which is mean that you need to do 1 minus probability of x greater than or equals to 6, because we can't find the probability of x less than or equals to using the binomial table, since our table just read probability of x greater than or equals to. So let us find the probability. N is 20 and p is 0 0.4. Probability of x greater than or equals to 6, which is 0 0.8744. So 1 minus 0 0.8744 is 0.1256. So the second question, more new cars are sold than the second-hand cars. So we have 20 cars. This consists of new car and second-hand car. So if we divide by 2, we're going to have 10 new car and 10 second-hand car. So if we like to sell more new cars than the second-hand cars, we're going to sell more than 10 new cars. So we're going to find the probability of x greater than 10, or you may write down as probability of x greater than or equals to 11, since the table cannot read greater than. Okay, so let us read from the table. X greater than or equals to 11. So we're going to have probability of 0 0.1275. So that is for the question A. Now let's answer the question B. During a 3-month period, 200 cars are sold. Using a suitable approximation, find the probability that less than 85 new cars are sold, 72 new cars are sold. Now, our distribution has changed, where the n has become extremely large, which is 200. So now our n is 200, but we still have the same p, which is 0 0.4. So using the suitable approximation, so we're going to approximate to normal distribution. Why we need to approximate to normal distribution because our n is greater than 50. So let's find the mean, which is NP, and the variance is NPQ. So 200 times 0.4 is 80, and 200 times 0.4 times 0.6, which is the Q, going to get 48. So that is for the variance. Now let us find the probability. Probability X is less than 85 new cars are sold, which is mean that we're going to do the continuity correction where we are not going to include 85 because the symbol here is less than. So we're going to do X is less than 84.5. So you also can do like this by drawing some number line. So we have 85, right? So it is X is less than 85. We don't want to include 85, so we need to take the value before 85. So 85 minus with 0.5, sorry, which is 84.5. Now we're done with the continuity corrections. Now let us standardize. Probability of Z less than 84.5 minus with 80 divide with square root of 48. Why we need to do the square root is, this is standard deviation and this is the value of variance. Okay, so to find standard deviation, we need to square root our variance, which is square root of 48. So now let's find the value of our Z score. 84.5 minus 80 divided with the square root of 48 is, so let us find the value correct to two decimal places. So Z is less than 0.65. Let's find the value of Z. Just before we find the value of Z, let us draw some bell shape. So this is 0.65, and this is the area of the probability Z less than 0.65. So if this is the probability of Z less than 0.65, then this is the probability of Z greater than 0.65. So to find the probability of Z less than 0.65 means we're going to do 1 minus probability of Z greater than 0.65. Now let us find the value of our Z score or the probability of Z greater than 0.65 from the table. .65 is, this is 0.6 and this is 0.65. Now we're going to add 0.05 on the top of the row. So 1 minus 0.2578. What's the value? 1 minus 0.2578 is 0.7422. Now the second question, the probability of 72 new cars are sold. So what we're going to do is going to find the value of the probability of X equals to 72. But before that, we need to do some continuity corrections. So 72 is going to be here. So we would like to include our 72, means we're going to find the value of, or we're going to do continuity correction, we're going to minus 72 with 0 0.5. We're going to get 71.5, and we're going to add 0 0.5. So we're going to have 72.5. Therefore, 72 will be included. Then the continuity correction is, so probability of Z greater than 71.5, and Z is less than 72.5. So let us standardize. We are not yet standardized actually. So just put X here. Okay. Now we would like to standardize. Then we're going to put X. Okay. So 71.5 minus with 80 divide with the standard deviations, which is square root of 48. Okay. Now we write down the variable Z. Okay. So 72.5 minus with 80 divide with square root of 48. And so what's the value of the Z-score first? 71.5 minus 80 divide with square root of 48 is probability of negative 1.23 and negative 1.08. Let's draw some bell shape. So this is negative 1.23, and this is the probability of negative 1.08. The area will be here. Okay. So if we symmetrical area to the right side, I'm going to find the probability as probability of Z greater than 1.08 minus with probability of Z greater than 1.23. Now, using the normal table or standard normal table, let's find the value of our Z-score. 1.08. So it's going to be 0.08, which is 0.1401 minus with 1.23. So 1.23, it is here, 0.1093. And let us find the difference between these two figures. 0.1401 minus with 0.1093, going to get 0.0308. That's it.